Auzu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Dear student, Assalamu alaikum. I am Dr. Muslim Khan, Assistant Professor, Department of Chemistry, KUST. Today, the topic of our discussion is concentration units. In Analytical Chemistry 1, the course code is CHEM351. As you know, that we have started different concentration units. As I told you before, that basically the solution is the homogeneous mixture of solute and solvent. So the amount of solute dissolved in a given amount of solution is termed as concentration. So while measuring the concentration of the solution, the strength of the solution, we say that this solution is 1 molar solution or 1 ppm solution or 1 ppb solution or 1 normal solution. So this ppb, this molarity, this molality, normality, and ppms, ppb, ppt, these are the different concentration units. Basically this represent basically the amount of solute dissolved in a certain amount of solution. So these are the different concentration units we want to discuss in this lecture. So in our previous lecture, we have discussed this mass percent, whether it is weight by weight or either whether it is weight by volume or volume by volume or volume by weight. We have discussed these in detail. We have also discussed molarity, molality, and we have done one example over here that how when you dissolve this amount of solute in a solution and what will be the molarity or molality of the solution. So in our today lecture, we will discuss the mole fraction. But before going into the mole fraction, I will tell you some a very very like a difference between molarity and molality, because usually this type of question are asked in different competitive exams, that what is the difference between molarity and molality. The one difference I told you in the definition of molarity and molality. That is, molarity is basically the number of moles of a solute dissolved per liter or per cubic decimeter of a solution. So this upper part of the molarity and molality is the same, because in a molality we say number of moles of a solute, but here we say dissolved per liter of a solution or per cubic decimeter of a solution. Here we say per kg of the solvent. So here is we are talking about solution, here we are talking about solvent, but this solvent in kg, here solution in liter. So this is the main difference. And the second thing is the molarity is temperature. This one is temperature dependent, but this is temperature independent. How? Like this one. As temperature is increased, the amount of solute remains same, but the volume of solution increases slightly as liquid expands. Hence, the molarity decreases and slightly due to the inverse relation. Here, you can see here in molarity, we are talking about the volume, because with increase in temperature or decrease in temperature, the volume slightly change, but you know that the mass will mass is independent of the temperature. So that's why this unit is independent of the temperature. I mean, when you take zero point 0.1 molar solution here on earth and zero point 0.1 molar solution here on earth, but if you take this to somewhere else, to some other planet, so this will remains the same, because this is the solvent in kg, so this is molality. this will not change. But then when you are going to the altitude or somewhere, the temperature increase or decrease. uh, this it means that molarity is temperature dependent unit, while molarity is temperature independent unit. So this was the small thing I want to tell you, because usually these type of questions are asked in the competitive exams. So, coming to the mole fraction, the next unit of the concentration of a solution. What is mole fraction? Is the name indicate? In the solutions, there are basically two fractions, two parts. One is solute and one is solvent. So, mole fraction is represented by X. So, the ratio of the number of moles of a given component to the total number of moles of a solution is known as a mole fraction. For example, mole fraction of a solute, x1 is the mole fraction of solute, n1 is the mole fraction of a solute, n1 plus n2. Sorry, this is missing here, but this is n1 plus n2. So the total number of moles of a solution. So mole fraction of a solvent x2. So the number of moles of a solvent divided by n1 plus n2, the total number of moles. So when you are calculating these two, because this is the ratio of a number of moles of a solute to the total number of moles of a solution, and here the number of moles of the solvent to the total number of moles of a solution. So this, when you are calculating x1 plus x2, so this must equal to 1. Okay. So this x1 will always be less than 1, x2 will always be less than 1, but the sum of the x1 plus x2 means the sum of the mole fraction of all the components present in the solution will be equal to 1k, because this is a mole fraction. So you are talking about one fraction in the total number of solutions basically. So coming to this example, for example, an aqueous solution containing 100 gram ethanol. So 100 gram ethanol per cubic decimeter, means per liter of a solution, has a density of 0.99 gram per cubic centimeter. Calculate mole fraction of each component of the solution. First of all, 1 cubic decimeter is equal to 1 liter. 1 cubic centimeter is equal to 1 ml. So 1 liter is having 1000 ml. So similarly, 1 cubic decimeter is having 1000 cubic centimeter. So mass of ethanol here given, that is equal to 100 gram. So mass of solution, density multiplied by volume of the solution. Density is given here and multiplied by 1000, volume of the solution. So mass of the solution is 984. So 984 minus 100. So mass of water. So because in a solution you have this this 100 gram of solute and the rest is solvent, because in a solution only there are two components. So mass of water will be 984 minus, this is of solution and this is of solute. So 984 of minus solute will be equal to 884 gram. So number of moles of water will be equal to 884 divided by molar mass of water, that is equal to 49.1 mole. So in continuity of this example, so number of moles of ethanol will be equal to 100 is the weight and 46 is the molar mass of ethanol. This is equal to 2.17. So the total number of moles in solution, water is of 49.1 plus 2.17. So these are the total number of moles. This is of ethanol, 49.1 was of water, and total number of moles of solution is 51.27. So now coming to the mole fraction of water, first of all. So the total is this one, and in total 49 is of water, of solvent. You know that solvent is that component of the solute which is present in a greater amount, in a large amount. So in 51, in total 51, 49 is of solvent, and the rest only 2 mole is of a solute. That's what is called solute when it is present in a less amount. So the mole fraction of water is 0.958 out of 1, and of ethanol 2.17 divided by 51 is the total, is 0.042 is of. So this, when you are adding up these two, this will be equal to 1, because this is always equal to, when the total number of moles of a solution will always be equal to 1, and of solute will be less than 1, and of solvent will be less than 1. So this is less than 1 and this is less than 1. So this is how you are calculating the mole fraction of a different components present in the solution. The next one is parts per million, ppm, as the name indicate. The number of parts by weight or volume of a solute per million parts by weight or volume of the solution is called ppm. So the difference between percent and ppm is, here you are calculating it in a million. Million is 10 raised to the power 6, and in percent you are calculating it in 100, so here multiplied by 100. So the formula is the same. ppm is equal to mass or volume of the solute, the total number of parts by weight, mass or volume of the solute, mass or volume of the solution multiplied by n million, that is called ppm. So coming to the example of ppm, first of all, for example, an atmospheric chemist reports that 1 cubic decimeter, 1 liter of air in urban are contained 3.5 multiplied by 10 raised to the power minus 4 cubic centimeter of carbon monoxide. What was the concentration of carbon monoxide in ppm? First of all, what is the formula of ppm? So volume of carbon monoxide in cubic centimeter, volume of air in cubic centimeter, multiplied by 10 raised to the power 6. So this is 3.5 and 10 raised to the power minus 4, and 10 raised to the power 3 of air. So multiplied by 10 raised to the power 6. So this is, it means that 0.35 ppm carbon monoxide is present in that urban area. So the next one is parts per billion. Parts per million and billions are the same. Formula is the same. The only difference is the multiplication here with the 10 raised to the power 9 instead of 6. So the number of parts by weight, mass, or volume of a solute per billion parts of a mass or volume of the solution is called ppb, parts per billion. So ppb is equal to mass or volume of a solute, mass or volume of the solution multiplied by 10 raised to the power 9. So coming to the example, for example, if the concentration of ozone in atmosphere reaches point ppb, zero point 0.5 ppb, what mass of ozone be present per kg of air? Means mass of ozone is given, mass of air is given, so we can calculate the ppb. So mass of ozone what is required, mass of air is given per thousand and 10 raised to the power 9. So mass of ozone required 0.5 ppb and 10 raised to the power 9. So zero point 0.5 multiplied by 1000 multiplied by 10 raised to the power minus 9 is equal to 5 into 10 raised to the power minus 7 gram of ozone will be present per kg of air. So this is how you are calculating ppb. The next one is parts per trillion. The number of parts by weight or volume of a solute per trillion parts by weight or volume of the solution. So PPT, so here and ppm 10 raised to power 6, and ppb 10 raised to power 9, and ppt parts per trillion 10 raised to the power 12. So ppt is equal to mass or volume of solute divided by mass or volume of the solution multiplied by 10 raised to power 12. So these were the different concentration units we talk about: PPT, ppm, molality, and mole fraction, etc. So sometimes you need to convert these units with each other. So one of the solution is given that this is 1 ppm. What will be the strength, this, and molarity? Other one is 2.1 molar. What will be the in ppm? So, for example, this is one of the example. Calculate the molarity of 15% weight by weight glucose solution. First of all, mass percent of glucose. So means 15% weight by weight. So means 15 gram is the mass of glucose, and what percent? 100 gram of solution. So mass of solution is 100 gram, but in solution 15 gram is of solvent, of solute. The rest is solvent. So 100 minus 15 is equal to 85 gram. So when you are converting this into into a kg, how you will do it? 85 divided by 1000 is equal to 0.085, because in molality you need your solvent in kg. So that's what. So you need number of moles of a solute dissolved per kg of solvent. Then you can calculate. So it means that you have a solution and percentage. You can easily calculate the molality of this solution. Like how? This. Molar mass of glucose is equal to carbon 12 multiplied by 6, 72, hydrogen plus 12, so 84, oxygen 16 multiplied by 6, is, is I think 96. So the total is 180. So molality, mass of glucose divided by molar mass multiplied by kg of water. Kg of water we have calculated in the previous, this one 0.085, and mass of glucose is this, and molar mass of glucose is 180. So putting it from in formula, 15 divided by 180 multiplied by this is equal to 0.98 molar solution. This is how what is called interconversion of molar solution. The same you can calculate it for molarity as well. But for molarity here, let's say you want to calculate it for molarity, the number of moles of a solute. So solute is this one, 15. Glucose is divided by 180. So this is number of mole dissolved per liter of a solution. So you convert this into a liter, then it is called, uh, this is this will be called a molarity, rather than molarity. So sulfuric acid is known as the king of chemical. It is used in the manufacturing of many chemicals, drugs, dyes, paints, etc. It is prepared commercially by contact process and is normally 98%. If you look the bottle of sulfuric acid in your chemistry lab, they will be written 98% by weight. And also the density will be there, 1.8 gram per cubic centimeter. What will be the molarity of this solution? It means that the solution percentage is given. You want to calculate molarity. In the previous example, percentage was given there. We want to calculate molality. Here, molarity. So next is how you calculate the molarity of this solution. Molar mass of H2SO4 is 98. Percentage of H2SO4 98%. Density is 1.8 cubic centimeter. So it means that 1 cubic centimeter sulfuric acid, gram per cubic centimeter means 1 cubic centimeter is having 1.84 gram. 100 will contain 1.84 multiplied by 1000. So it is equal to 1840 gram of sulfuric acid will be there in 100 ml of sulfuric acid solution. So mass of H2SO4 in solution. So There are 98 in 100, but how much it will be? 1840. So that will be 1830.0 gram. So moles of H2 support solution. This one divided by molar mass. 18.4 moles per 1000 ml. So molarity of H2SO4 solution will be equal to 18.4 moles per curie. So 18.4 molar solution will be this sulfuric acid. So this is how you are calculating when you know the strength of solution in one unit and you convert it into other unit. The rest we will discuss in our coming lecture. Thank you very much.